Alright, we're going to talk about the fundamentals of process control. So process control is a system that combines measuring materials and controlling instruments into an arrangement capable of automatic action. Usually requires more than measuring and controlling the physical and chemical characteristics of a process material. So a variable is a value that is measured by an instrument, and there are different types of variables. So a process variable is the dependent variable that is to be controlled in a control system. So this could be temp, pressure, level, or flow. A control variable is the independent variable in a process control system that is used to adjust the dependent variable. So that could be flow rate of steam or flow rate of refrigerant. A set point is the desired value at which the process should be controlled and is used by the controller for comparison with the process variable. So it can be set by the operator or engineer, but also is sometimes set by the control system. Automation. So process automation refers to processes involving batch and continuous flows of liquids, gases, and bulk solids. Some examples are chemical reactions, cooling and heating, and mixing and separating products. They can be used for factory automation, usually involves the piece flow of products, used in discrete part manufacturing like assembly, moving, and transporting. So here's some control elements. So these are going to be variables such as temp, pressure, flow, level, humidity, density, viscosity. Process control is used to control these variables. So the system will use a primary element, a control element, and a final element. The primary element is going to be the sensing device that detects the condition of the process variable. So that's going to be thermocouples, pressure gauges, level gauges, and flow meters, stuff like that. The control element is a device that compares a process measurement to a set point and changes the control variable to bring the process variable back to the set point. So that could be air pressure, electric current, or voltage. The final element is a device that receives a control signal and regulates the amount of material or energy in a process. So this could be control valves, hydraulic pistons, variable speed drives, relays, pumps, and dampers. A measuring element is a device that establishes a scaled value for the measured process variable. So temp transmitter is a measuring element that converts a thermocouple voltage to a scaled temp value. Performance characteristics. The elements of a control system, such as instruments, controllers, and final elements, are subject to performance limitations. Example, a temp sensor primary element takes time to respond to changes. A sensor and a protective cover responds more slowly to a temp change than an unprotected one. They can be classified as either static or dynamic characteristics. So your static are going to be the characteristics of an element that describe the operation of the element at steady state conditions when the process is not changing. Range is the boundary of the values that identify the minimum and maximum limits of an element. So a temp sensor may have a range of -50 Fahrenheit to 200 Fahrenheit. Bias is a systematic error or offset introduced into a measurement system. A temp sensor may read 2 degrees high under all conditions. This bias may be intentionally introduced into control strategy. Accuracy is the degree to which an observed value matches the actual value of a measurement over a specified range. No standard definition, and it may vary between manufacturers. Precision is the closeness to which elements provide agreement among measured values. Precision does not describe the same thing as accuracy. Only measures agreement among the measured values, does not compare the measured values to a standard or a true value. And then dynamic characteristics are the characteristics of an element that describe the operation of the element that describe, I wrote that twice, at unsteady state conditions when the process is changing. Reproducibility is the closest of agreement among repeated measure values when approached from both directions. So when a thermocouple voltage is measured, control signal can be generated to adjust a process. Response time is the time it takes an element to respond to a change in the value of the measured variable or to produce a 100% change in the output signal due to a 100% change in the input signal. So for example, if the temp of a material changes, response time determines how quickly a temp sensor indicates or records that change. Fidelity is the ability of an element to follow a change in the value of an input. Dynamic error is the difference between a changing value and the momentary instrument reading or the controller action. Hysteresis is a property of physical systems that do not react immediately to the forces applied to them or do not return completely to their original state. So conditions depend on their immediate history. They may be caused by frictional or magnetic forces, and they can affect valve actuators. Stability is the ability of a measurement to exhibit only natural, random variation where there are no known identifiable external effects causing the variation. A pressure measurement has stability when external effects, such as valves closing and pumps starting, do not affect the pressure being measured. Linearity is the closeness to which multiple measurements approximate a straight line on a graph. Nonlinearity is the degree to which multiple measurements do not approximate a straight line on a graph. Control loops. An instrument loop is a control system in which one or more instruments are connected together to perform a task. So you got a control loop. Is a control system in which information is transferred from a primary element to a controller, from the controller to the final element, and from there to the process. So it may measure and control many variables in a process at the same time. A closed loop is a control system that provides feedback to the controller on the state of the process variable due to changes made by the final control element. So a good example of that would be a thermostat. A thermostat, if it's set to 74 degrees and it senses that it's 75, it's going to kick on. It's going to send a control to that HVAC unit, and then once it gets back down to 74, it's going to cut off. So that would be a closed loop system. Open loop is a control system that sends a control signal to a final element that does not verify the results of that control. So it exists if the feedback is absent or disabled. And some control strategies. A control strategy is a method of determining the output of a controller based on the input of the controller and the set point of the process. So a signal is sent to a controller. You've got on-off, and that control is the simplest and most common. And you've got proportional, and that control uses the difference between the set point and the process variable to determine a control output that is sent to a final element. A level controller for a tank of water opens and closes a valve based on the position of a float. So the controller is going to adjust the water accordingly to it being high or low. And last, instrument calibration. So this is often required as part of a maintenance program or to meet the requirements of a standard. So calibration is used to certify that an instrument meets performance requirements when tested with calibrated and certified equipment. Calibration can be kept track of with management software, and it can be done in-house or contracted out to a third-party company. So, for example, when I worked for Southern and they would go around and do testing on turbines and boilers and stuff of that nature, before that equipment got sent out to the plant to be set up to where they could conduct testing, everything had to be calibrated. So all the way down to the thermocouples, they would have to calibrate them, run the software, and prove that they were calibrated to a certain extent before they could be used. So you had to prove that everything was in tip-top shape before you could test something. And that is all for Chapter 2.